So lesson 4, we're going to talk a little bit about the periodic table here. Obviously, it's arranged in a very specific way. It's based on elements that have similar chemical properties. That's how we get the groups here, right? Groups of elements are found in vertical columns. So vertical columns, of course, implies that they're going up and down, right? So why are all these elements here? Why do they all happen to be here? Because they all have one valence electron, right? Group 2 has 2 valence electrons. 3 to 12 gets a little sketchy. We'll talk about that, but and then we get over to the other side there, 15, 16, 17, 18. Group 18 has all filled outside energy levels. So that's what makes them all the same and kind of a low reactivity or no reactivity in some cases. So groups of elements are found vertically. And then, of course, we have here periods of the elements, right? And the periods go left to right. And basically what happens in a period is basically we can say this. Well, they have the same number of energy levels for the most part. So like, especially with group 2, or sorry, period 2, I should say, period 2 here, which is, no, actually you guys are period 3, aren't you? Let's go with period 3. So period 3, that's this one across there, of course. They all have electrons that are in the 3rd energy level, yes? So that's kind of what they have in common, I guess. But also they just go from very metallic to very non-metallic, okay? And it kind of slides in there. We're going to talk about very metallic to non-metallic, and then of course we have metals on the left side, we have non-metals on the right, which was the next notes we're going to take here actually. But we also talk about metalloids a little bit as well. So those are metals or non-metals that have properties of kind of both metals and non-metals, right? And they're the ones that straddle that staircase there, that orange staircase. Or if you have your periodic table out, it's like it's just a darker shaded line there, I think. Okay, so good. Metals are found to the left, so you can write that down in your little metals thing there. Metals are found to the left, I think. I don't know what I said. Metals are to the left, non-metals are to the right, and then we have metalloids, and they straddle the staircase. Okay. Now, a couple things. So you will have to fill in a few things here, and I kind of underlined the first one for you. Some of this is already there for you, but there's a few things that are missing. So group 1, make sure you spell these correctly, all right? This is the alkali metals. That's it, alkali, okay? So make sure when I ask you this quiz question down the road, it won't be on Tuesday, but down the road here, let's make sure that we are writing that down appropriately, okay? Alkali metals, they're soft and silver is what that says. I don't know if you can, there we go. They're soft and silver. And I will show you this one of these days here. We might have to, just for convenience sake, we might have to go they're most reactive of all the metals. Reactivity increases as you go down the group. So group 1, of course, is, hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. And basically, reactivity increases as you go down because they all have one valence electron. But here's the deal. Where's the valence electron in relation to the nucleus? We'll talk a little bit about this in about lesson 9 or so roughly as well. So if my head is the nucleus, okay, hydrogen has 1 electron, so it's like right here, yes? But when you get to lithium, okay, you got 1 energy level. Lithium's extra electrons here now, yes? And then when we go to sodium, it's here, that extra electron. Potassium, rubidium, now the electron's a little farther away. Cesium, and francium, yes? So that extra electron's way out here now. So how easily can it lose that electron? The answer is very well, because the job of the protons is to keep the electrons in the orbit, yes? But that 1 electron so far away, it's got a really tough time to do that, okay? And that's why francium is the most reactive metal. That extra valence electron is really far away from the nucleus. Anything else that comes along is going to want to grab that from there, okay? So reactivity increases as you go down the group. It's also true for group 2 as well. It's just that they're not as reactive as group 1. Group 1 is always the most reactive, okay? All right. They can easily react with water. I'll show you that to produce hydrogen gas and a basic solution. Next, group 2. I think you have to fill in these things here and, of course, the name as well. So group 2, remember now, a little bit different wording here, alkaline earth metals. So we've got to put the ion on there and the earth metals. Yep. Yep. Is that okay? And so group 2 alkaline earth metals, they're light reactive metals that form an oxide coating. So if you, we're going to go look at some calcium, or we could look at magnesium as well, I guess. But calcium especially doesn't look like a lot, like does not shiny and bendable and things like that, because it's got this oxide coating that kind of prevents it from further reaction. Okay, they're really good at forming this oxide coating. Reacts with basically when exposed to air. The metal oxide layer protects them from further reaction, and they're not as reactive as group 1. So if you ever get like, you know, some atoms to pick from and you're like, which one's the most reactive, you always pick group 1 elements. Group 1 are always way more reactive. Okay, it doesn't matter. You know, again, we talk about reactivity as you go down the group, but sodium is still more reactive than even, for example, radium. Okay, so yeah. Okay, good. Next. 3 to 12. 3 to 12 are called the transition metals. Transition metals. They have a wide range of chemical and physical properties. They can be multivalent, which basically means that they form more than one charge. So titanium comes in a 3+ and a 4+. This is where we're going to have to write Roman numerals and things like that, right? Titanium 3 chloride, titanium 4 chloride, things like that. Okay, and we'll do that next week here. As with all metals, the transition metals or transition elements are both ductile and malleable to conduct electricity and heat, which we're going to talk about coming up. Group 17 are called the halogens. They're the most reactive of the non-metals, and now it's the opposite. Reactivity increases as you move up the group. So the most reactive non-metal we have, most reactive non-metal, is actually fluorine. All right. So fluorine's the most reactive there, non-metal. Francium is the most reactive metal. Okay, maybe just remember that, but that's how it works. Okay, it's kind of just the complete opposite, because of course, look, francium's trying to get rid of electrons because it's a metal, so it's got one valence electron, but it's like way out here somewhere, and it's trying to get rid of that extra electron to have a full outside energy level. So it does that very easily because there's so much distance between the nucleus and that farthest out electron, right? So it can lose it easily. But fluorine is doing the opposite. Fluorine has 2 and then 7, and it's looking to gain 1. So because the nucleus is here and the second energy level is here, it can quite easily, that nucleus can attract another electron fairly easily. It gets a little harder when we get down the table because now fluorine's here, okay? But then we get to chlorine. Well, now to gain that extra electron, the nucleus is here, but we're trying to gain electron here. It's a little farther distance. And then we got bromine and iodine kind of thing, and acetine, and iodine's out here, and it's trying to gain that electron way out here. It's a little tougher for it to do that, okay? So it's kind of just the complete opposite of the metals. So fluorine's the most reactive non-metal, francium's the most reactive metal, okay? Kind of the opposite thing. We'll look at that again, like I said, when we talk about something called electronegativity, okay? Yeah, they can easily gain 1 electron to fill their energy level, okay? And then last one here we have is group 18, which are, of course, the noble gases, right? Noble gases have extremely low reactivity because they have a completely filled valence energy level in each of the neutral atoms. And we say that all noble gases have 8 electrons in their outside energy level, or shell, making them stable. Today was a good day for that because it's Friday, it's short, so it's not a bad day to do notes, I guess. And but on Tuesday we'll do some actual homework. It'll be good. Noble gases, like I said, really low reactivity, not reactive, not very reactive, and so on. Now this is all there for you, but just a real quick reminder here, okay? At some point, I'm probably going to ask you to compare some metals versus non-metals. So what are some properties of metals versus non-metals? And the answer is, well, when you go to compare them, make sure you tell me about both of them, okay? So example, you know, most metals that we deal with are solids at room temperature, okay? Look on the periodic table. on your periodic table or mine. And when I look over there on my periodic table, I see all, if we look at the left side of the staircase, pretty much all of them are in gray lettering. And that to me means it's a solid. Okay, there's a reason that metals tend to exist as solids, and we're going to talk about why that is. Okay, why are metals, almost all of them are solids, except for, of course, mercury, which is the exception. But all the other metals are solids. Why is that? Okay, so we're going to look at that. And when you go to say non-metals, what about non-metals? So if you're going to compare them, which I'm going to ask you to do at some point, I don't want you to say non-metals aren't. Okay, that's not true. Metals are solids. Non-metals tend to be solids, liquids, or gases. Okay, and you can tell that by when I look at my periodic table. Again, yours is a little different, but I look over there, I see some gray lettering. I see bromine is blue. Okay, that's liquid, and then the red ones are the gases. Okay, so we have kind of a mixture there. Why are those? Why are some non-metals solids? Why are some liquids? Why are some gases? We're going to talk about that as well. All right. Metals are only atomic elements. So when you're walking down the street and you see a metal like magnesium, okay, like we were talking about yesterday on the way to 7-Eleven, that's by itself probably. Okay. You could find atoms that are them by themselves. Non-metals can be either atomic, so carbon, or they can come in twos, or sometimes fours or eights, like phosphorus comes in fours, or chlorine comes in twos, because they're helping each other become more stable. Okay. Metals tend to be shiny, bendable, malleable, ductile. Non-metals, don't say they're not. Okay. Give me some descriptions here. Metals are shiny. I'll show you that when we go to the lab one of these days, or whatever we do with that. Metals are shiny. Aluminum foil. Most of us know what aluminum foil looks like at home. Shiny, it's bendable, it's malleable. You can bend it and work with it, hammer it, okay? And ductile means you can pull it into a wire kind of thing, right? Non-metals tend to be dull and brittle. Most of you know what a pencil looks like. You push too hard on a pencil, it's not very shiny. You push too hard on a pencil, it'll break, okay? That's carbon to carbon bonds. Metals are good conductors of heat and electricity, all right? They tend to conduct electricity very well. Again, there's a reason for that. And we'll talk about that. Non-metals are poor conductors of heat and electricity. Some maybe do not, but they tend to be very poor at conducting heat and electricity. Okay, so those are just some comparisons that we need to know down the road, but not maybe for right now. Okay, good, good.